We're looking at ratios, proportions, rates, and unit rates. So for our definitions, a ratio compares two values. And some examples that you might see: a ratio of blue-eyed students to the entire class, which is 11 to 27, or the ratio of milk to oatmeal and cereal is 1 to 3/4, or the ratio of tea to lemonade in an Arnold Palmer drink is 5 to 2. And you've got the colon, or you can use the word to. But ratios can also be written as a fraction. And you always want to label your values with the appropriate units. Here they've named them. They've said blue eyes to the entire class, and it goes 11 to 27, so the 11 are the blue eyes. So when we go to put the ratio, when it's labeled blue eyes, that's going to have to be the 11. And then they say to the entire class, well then the 2, the 27 would be the whole class or the entire class. Then the second ratio, it's milk to oatmeal, and the cereal is 1 to 3/4. So when we go to label these, milk goes with 1 to oatmeal, which is 3/4. So we'll label that milk. Whoops, okay. All right. Sorry about that, but that's milk. To cereal, or oatmeal, we can say, is 1 to 3/4. Now, the last one is 5 to 2, lemonade. Oh, tea is 5 to lemonade, which is 2. So 5 parts of lemonade to 2 parts of tea. Now, if you notice in the ratios, it doesn't actually say whether it's cups, pints, liters. It's just a ratio, and you could put in whatever values you want, but they'd have to be the same. 5 cups to 2 cups, 5 liters to 2 liters, whatever you want to do there. But then when we go to rates, a rate is similar to a ratio. It compares two quantities, TIES, measured in different units. So now we're looking at units that are not the same. So some common rates that you've seen before, they're called unit rates, which are special because they have a denominator that is equal to 1. And some examples here: if you say 55 miles per hour, since there's no number on the hours, it means 1 hour. So that would be written as 55, and then that's miles, and then the per is the fraction bar, and then hours, well, it'd be 1 hour. That is a unit rate with a denominator of 1. Okay, so for heart rate, we could do the same thing. So what I'm going to have you do is stop the video and find your heart rate, and you find it on your wrist, right below your thumb, past these little... those are, they attach the muscle to the bone. I'm having a blank. Tendons. Okay, so right past these tendons, underneath the thumb, if you push with your pointer finger and your middle finger, right there, you should be able to feel your pulse. So pause the video, find your pulse, and when you come back, I'll time you for 10 seconds. So go ahead and pause the video. All right, so here we go. Ready? Go. And stop. Okay, so however many beats you have, I'm just going to pretend that this person has 9 beats. You put how many beats you have in 10 seconds. So a nurse that's going to do that, they want to know how many beats you have in 1 minute, because on their chart they'll have to fill in BPMs, which means beats per minute. So to get seconds to be 60, which is 1 minute, they would have to multiply the numerator and denominator by 6. So that means it would be 54 beats in 60 seconds, which then would be the same thing as 54 beats per minute. So the nurse would put in 54 there. but they're not going to take your pulse for the whole minute. Now, just another thing you could do is convert it to hours, and if you did that, there's 60 minutes in an hour, so you'd have to multiply by 60 over 60, and 60 minutes would be the same thing as 1 hour, so 60 times 54. I would take 60 times 50, which would be 3,000, and 60 times 4 would be 240, so that'd be 3,240 beats per hour. But beats per minute is how you normally want to see that. Okay, but all of these ratios right here, every one of them are equal, so we say they are proportional, and we'll come back to that idea in just a minute. Okay, so just some practice here, or examples. We're going to write these as unit rates. Well, that's easy. 60 miles per 1 hour, and what we're saying is we're writing them as mathematical unit rates. $12 per 1 hour, because it's $12 per hour, and 10 cents, 0.10, with a dollar sign, 10 cents per 1 minute. So mathematically, that's how we're going to write them. Okay, so then on the second page, we have what a proportion is, and that's two ratios or rates which are equal. And we're going to come back on the video part 2. This is part 1 because it went too long, and so I had to do 2 parts. And if you also notice that I had to redo this one because I did it sideways when I downloaded it. Not sure how that happened. But anyway, proportion are ratios or rates that are equal to each other. And just one thing that I talk about at the end of the part 2 is that if you have two fractions that are equal, let's take 2/3 and I'm going to multiply by 15 over 15. So I'm going to make that 30/45. I know those are equal. But I could check to make sure they're equal by cross multiplying. So take 2 times 45, get 90, and then 3 times 30, we also get 90. Okay, and these are equal, so these two ratios are proportional. They are equal. At the end of the video, and what you're going to have to do for your exit ticket tomorrow, is you're going to have to tell why we can cross multiply on a proportion and the cross products are equal to each other. All right, so then example 4, to make 4 large pizzas, Paul needs 14 cups of pepperoni. Okay, so that's important information. 4 large pizzas, 14 cups of pepperoni. And we want to know how much pepperoni does he need for 1 large pizza. So how much pepperoni does he need? How about we make that X for pepperoni? And it's actually going to be cups of pepperoni, so X cups per 1 pizza. So there's our unit rate. So it's going to be X cups per 1, and I'm just going to put 1 PIZ for pizza. And we know that the ratio that we have, we just want to cut the recipe to only have 1 pizza, but the recipe we have calls for 14 cups, so we're going to put 14 cups across from X cups. And we have 14 cups for 4 pizzas, so we'll put 4 pizzas.